Introducing alpha particles. Alpha particles are like tiny bullets of matter, moving with incredible speed and energy. They are so small that we can't see them with our eyes, even with the most powerful microscopes. But despite their minuscule size, they are incredibly powerful and can travel at very high speeds. Imagine a tiny particle, smaller than an atom, zipping through space at astonishing velocities. That's an alpha particle. These particles are made up of even smaller particles called protons and neutrons, which are the building blocks of matter. Alpha particles have a positive electric charge because of the protons they contain, giving them unique properties. This positive charge influences how they interact with other particles and materials, making them significant in various scientific fields. Understanding alpha particles unlocks a fascinating realm of science, from the fundamental principles of physics to practical applications. They play a crucial role in radioactivity, nuclear reactions, and even some advanced medical treatments, such as targeted radiation therapy for cancer. Alpha particles consist of 2 protons and 2 neutrons bound together. This composition gives them a mass number of 4 and an electric charge of +2. Protons and neutrons reside in the nucleus, the central core of an atom. In an alpha particle, these particles are tightly packed together, creating a stable structure. The 2 protons give the alpha particle its positive charge, while the neutrons contribute to its mass but not its charge. The strong nuclear force binds these particles together within the alpha particle. This unique combination of particles and their arrangement gives alpha particles their distinct properties and behavior. Section 3. Unstable giants, the source of alpha particles. Alpha particles originate from the decay of certain radioactive atoms. These atoms are unstable and release energy and particles to become more stable. Radioactive decay is a natural process where the nucleus of an unstable atom undergoes transformation. This process releases energy and often particles, including alpha particles. Elements like uranium and radium are examples of radioactive elements that emit alpha particles during their decay. These heavy elements have large, unstable nuclei. When an atom undergoes alpha decay, it ejects an alpha particle. In doing so, the atom transforms into a different element with a lower atomic number. Section 4. Journey of Discovery. Unveiling the secrets of radiation. The discovery of alpha particles marked a pivotal moment in scientific history. It revolutionized our understanding of matter and the atom. In the late 19th century, scientists like Henri Becquerel and Marie Curie made groundbreaking observations about radioactivity. They noticed that certain materials emitted mysterious rays. Ernest Rutherford, a physicist from New Zealand, played a crucial role in identifying and characterizing these rays. He conducted experiments to study their properties. Through his experiments, Rutherford discovered 3 types of radiation: alpha, beta, and gamma rays. Each type differed in its penetrating power and behavior in electric and magnetic fields. Section 5. Rutherford's gold foil experiment. Alpha particles in action. One of the most famous experiments in the history of physics, Rutherford's gold foil experiment utilized alpha particles to probe the intricate structure of the atom. In this groundbreaking experiment, Rutherford bombarded a very thin gold foil with a focused beam of alpha particles. He initially expected that most of the alpha particles would pass straight through the foil with very little deflection. To his great surprise, a small fraction of the alpha particles actually bounced back or were deflected at very large angles. This unexpected result posed a significant challenge to the prevailing model of the atom at the time. Based on his observations, Rutherford was led to propose a revolutionary new model of the atom. He concluded that the atom must contain a small, dense, positively charged nucleus at its very center, which was a groundbreaking discovery in atomic theory. Section 6. Alpha particles in our lives. Applications and uses. Alpha particles, despite their potential risks, find applications in various fields, including medicine, industry, and scientific research. In medicine, alpha particles are used in radiation therapy to treat certain types of cancer. They can target and destroy cancer cells with high precision. The industrial applications of alpha particles include smoke detectors, where they ionize air particles, and static eliminators, where they neutralize static charges. Scientists utilize alpha particles in research to study the properties of materials and to probe the structure of atoms and nuclei. Section 7. The two-sided nature of radiation risks and precautions. While alpha particles have beneficial applications, it's crucial to acknowledge and address the potential risks associated with radiation exposure. Alpha particles possess high ionizing power, meaning they can strip electrons from atoms as they pass through matter. This ionization can damage living tissue. External exposure to alpha particles is generally less concerning because they have low penetrating power and can be stopped by a sheet of paper or a few centimeters of air. However, internal exposure, where alpha-emitting materials are ingested or inhaled, poses a more significant risk. It's essential to handle radioactive materials with care and follow safety guidelines. Section 8. Fun facts about alpha particles. Did you know? Let's delve into some intriguing facts about alpha particles that highlight their unique characteristics and significance. These tiny particles have a fascinating story to tell. Did you know that alpha particles are relatively heavy compared to other forms of radiation? This makes them quite unique in the world of subatomic particles. They are about 4 times heavier than a proton, which is a significant difference when you consider the scale of atomic particles. The speed of alpha particles can reach up to 10% the speed of light, which is incredibly fast. Imagine something so small moving at such a high velocity. Americium-241, an alpha emitter, is used in smoke detectors. This application is a perfect example of how science can be applied to everyday safety. It ionizes air particles, and smoke interferes with this process, triggering the alarm. This simple yet effective mechanism has saved countless lives. Alpha particles played a crucial role in the discovery of the nucleus of the atom, revolutionizing our understanding of matter. This discovery was a milestone in the field of nuclear physics, changing the way we perceive the building blocks of the universe. Section 9. Conclusion: the enduring significance of alpha particles. Alpha particles, those tiny bullets of matter, have captivated scientists and fueled scientific advancements for over a century. Their discovery unlocked a deeper understanding of the atom, radioactivity, and the fundamental building blocks of the universe. From Rutherford's groundbreaking gold foil experiment to the development of life-saving medical treatments, alpha particles have left an indelible mark on science and technology. While their ionizing power necessitates careful handling and precautions, their applications in various fields continue to benefit society. As we delve deeper into the intricacies of the quantum world, alpha particles remain essential tools for exploration and discovery. Section 10. Further exploration. Delving deeper into the world of radiation. The world of radiation and subatomic particles is vast and fascinating. If you're eager to learn more, consider exploring these avenues. Read books and articles about radioactivity, nuclear physics, and the history of atomic theory. Explore online resources like educational websites, videos, and interactive simulations to visualize and understand the concepts better. Visit science museums or attend lectures and talks by experts in the field to gain further insights. The pursuit of knowledge is an enriching journey. Embrace your curiosity and continue to explore the wonders of the universe around us. Happy learning!